Okay, more exciting stuff on radicals. Now, you probably want to do this one by one. You're doing the same thing on 1 and 2, and then different thing on 2 and 3, and then 5 and 6 are completely different. You need to simplify this little formula here. So here's what you do. You have this -2 as a multiplier, okay? So then you write times, and you start taking that 20 and you're trying to divide. By the way, it's a 2 as a perfect square if you don't see anything. So we're on our perfect square list. Remember, we got 2's and 3's, and then 4's, 5's, and 6's. So 20 on my perfect square would fall between 25 and 16. So 20 is the number. 16 does not work. Now try 9. 9 does not work. Then we try 4, and that does work. So make 2 roots, put them times each other, okay? And then you're going to put 4 and 5. Now they're both second roots. Now the first root you eliminate because that has an equal, and the equal's 2. Then what you do is you multiply -2 by 2, and that makes, I multiply these two, and that makes -4 with a square root of 5. Okay, my next problem, I drop the 5 and write a multiplication sign. That's the operation. Now you're on cubed roots, so you need to take 250, perfect cube, and 250 is not on the list, so I would start between 343 and 216. So 250 divided by 216 decimal. 250 divided by 125. Okay, we got it. And then I make 2 roots. Make sure you put cubes. And it was 125 and 2. So 125 goes first, then 2. And this is eliminated and replaced with its equal of 5. Okay, so I multiply 5 times 5, and that's 25 with a cubed root of 2. Okay, next problem, I drop my 7, and I'm on 4th roots now, so that's second and thirds, so 4th list is right here. And I start dividing 486, so I'd start with 486 divided by 256, that did not work. 486 divided by 81, that does work. Okay, so I put the 2 roots, and I put 4, 4, and then 81 and 6. Okay, replace your 4th root of 81 with the integer that it equals, which is 3, and then that allows me to multiply 7 times 3, and that's 21 with a 4th root of 6. Okay, next one, I got -4 times, and then I take 96. Now I'm on fifths, so I'm down here. 96. It's either 32 or we got a problem. Okay. If you can't divide, that would be just the answer, but it can be. Okay. So I put 32 and 3. And those are 5th roots. And I know this is equal to an integer, and the integer it's equal to is 2. Say, so -4 times 2 is -8, and then a 5th root of 3 right next to it. Okay, pause the video and go do numbers 1 and 2 on the assignment. Okay, now that you unpaused it, now you got some operations to do with radicals. 3 radical cubed root of 54 times 5 cubed root of 7. The roots will be the same. If they're not, you can't really do much. Now, multiplication operation has a 3-step procedure. Okay, the first thing you do is you multiply the outsides. 3 times 5, and that's 15. And then I put a cubed root, and then I multiply the insides. 54 times 7. 378. Okay, that's first step. Easy enough. That times that, and then the cubed root, that times that. Okay, so I need to take 378 and see what it divides by, and the right list would be the perfect cubes. So I turn over. So 378 is between here. So does 378 divide by 343? No. Does it divide by 216? Nope. How about 125? Yes. No. No. Doesn't divide by 125. So 378 by 64. 378 by 27. Okay, I got it to work. So I drop my 15 times, and then I'm going to put 2 cubed roots, and I'm going to break it into 27 times 14. And then step 3, I need to eliminate that, because that has an equal of 3. And then step 3, all you got to do is take 15 times 3. And that's 45 cubed root 14. Okay, now here, remember, these are square roots. If you don't see numbers, it's automatically a square root. So I'll be taking 2 times 3, which is 6, putting square root, and then I'll be taking 60 times 5, and I get 300. Okay, so I drop my 6, and then I want to look at my perfect squares, because it's a square root, the list I'm most familiar with. So I guess it's at the end, so we start 300 by 144. 300 by 121 is a fail. 300 by 100, that works. Okay. So I break this into 100 times 3. Okay, get rid of your square root of 100, and we know that that is equal to the number 10. And then 6 times 10 is 60. Remember, it's times here. So 60 with a square root of 3. Okay, more multiplication. So it's 3 steps. So 5 times, and then remember, these are square roots. So 5 times 7 is 35, and I put a square, and 9 times 7 is 63. So I drop my 35. Whoops, sorry, I jumped the gun. First divide 63 into some of these perfect squares. So 63 by 49 doesn't work. 63 by 36 doesn't work. 25, no. 16, no. And then 9. Okay, I got it to work. So I break this into 9 and 7. That's got to go because that's equal to 3. And now we take 35 times 3, which is 105 square root 7. Okay, next one, little multiplication there. So 1, 2, and 3. The multiplication operation with radicals is always 3 steps. 2 times negative 4 is negative 8. That's a 4th root. And then I take 50 times 16, and that's 800. So I drop my negative 8, and I write a multiplication sign. Then I start trying to divide 800, not by squares or cubes, but by 4s. So you have to be on the right list if you're going to know how to do this, okay? So 800 by 625, nope. By 256, nope. By 81, nope. Either 16 or we're out of luck because 1 doesn't really do a lot of good. So I break it into 2 4th roots, and I put the number that I divided by from the list and then the answer I got. So we replace the 4th root of 16 with its integer equal of 2. Then I multiply, I get negative 16 4th root over 50. Okay, now pause the video and do 3 and 4. Okay, now the operation's not multiplying, it's adding. And these are 2. Adding's a whole different ballgame. It's not even close to the same thing as multiplication. You can't add anything until you get the numbers underneath the roots, the radicals, to be the same. So they're both square roots, but we have a 50 here, a 72 here. So here's the best way. You're going to make this chart, and on one side you put 3, square root 50, and on the other side you put 7, square root 72. So I go 3 times, and I go 7 times, and then on my perfect square list, because it's a square root, we start dividing 50, those numbers into 50. So it's perfect squares, one I'm most familiar with, so 50 is between these two. So 50 divided by 49 is a decimal. 50 by 36 a decimal. 50 by 25, that works. So I put 2 square roots, and I'm going to be putting 25 and 2. Eliminate him, because he's equal to 5. Then 3 times 5 is 15, okay, with a square root of 2. Now, you can get this other one pretty quick because you know a 2 has to be in this, okay? And then I can just divide 72 by 2, and I would put 36 in the other root. And that's always going to be on the list. 36 is here, and that's 6. 7 times 2 is 42, square root 2. Now, since it's like adding x's, so what you do is you put the square root of 2, because that's common to both, and then you add 15 to 42. 15 plus 42 is 57. Here, I'll even put that, 15 plus 42. Now the operation's subtraction, but I'm going to make that addition of a negative 5, and then I do the same thing. Negative 3 cubed root of 16, and then negative 5 cubed root of 250. So I drop my negative 3, drop my negative 5. So now I need to be on my cubes, and 16's not on the list, so I start trying to divide. It's between here. So it better divide by 8, which it does. So I make 2 cubed roots, and I put 8 and 2. We always get rid of this one because that has an equal, and that's 2. Negative 3 multiplied by 2 is negative 6. And you multiply these. I know adding is in the middle, but this is still times. A lot of people add negative 3 and 2. That's wrong. Okay? I don't add till I have both of them figured out. Okay? And then the second one goes pretty quickly because, listen, you know that this needs to be a 2. Then you divide 250 by 2 to find the other one. That's 125. So we can take him out because he has an equal. He will always have an equal. And he does, it's 5. Then I multiply negative 5 by 5, negative 25, cubed root 2. So I got the cubed root of 2, and then that allows me to add the outsides together, and that's negative 31. Okay, now the next one, you can put a 1 there if it makes you feel better. Okay, 7 fourth root of 405, and then 1 fourth root of 3,125. So I have 7 times, you have 1 times. You really don't need the 1 there, but if it makes you feel better, go for it. So now we're on the fourths. We're going to try to divide those numbers into 405. So 405 is between here, so 405 divided by 256 decimal. 405 divided by 81 works. Okay. So I put my 2 fourth roots, and I put 81 and 5. Okay, so we know that has an equal of 3. That's why you divide by those, and that makes 21 fourth roots of 5. Okay, now we all know that I should be having a 5 here if I want to be successful in carrying out the operation. So to find the other one, we divide 3125 by 5, and I get 625. And this here should be on the list. Okay, it has an equal. That's 5. So 1 times 5 is 5, fourth root of 5. So what's common to both is the fourth root of 5. And now I'm able to add 21 plus 5, the outsides, and that's 26. Okay, the subtraction, you put plus negative. And you have 2 with a fifth root over 64. negative 6. The roots have to be the same, like 5 or 4. They can't be different, or you really can't do the operation. So I have 2 times, I have negative 6 times. So start trying to divide 64, or sorry, my bad, 64, yeah, 64 by your fifths. So it's pretty much 32, because the other numbers are bigger, and it's 2. So I put 5, 5, and then 32 and 2. This gets replaced with its equal, which is 2. 2 times 2 is 4, and then we have the fifth root of 2 next to it, multiplied by it, which means it just sits next to it. Okay, now the second one should go a little quicker, because what do we have here? We have a 2. I know a 2's got to go in there. So 486 divided by 2 is 243. And that should have an equal. Okay, it does, it's 3. So negative 6 times 3 is negative 18, fifth root of 2. So it's the fifth root of 2, and I'm able to add 4 to negative 18, and that's negative 14.